1, 2? All right. So actually, before we start, kind of a tip for those presenting and never tried this lovely feature in Windows 8. You can just disable notifications, and this way you won't have to share what your wife is doing with all the audience. For those who attended the session earlier today, they understand. All right. So I think we're good to go, right? My name is Ziv Rafalovic. Thank you for inviting me, the BizTalk team, to this BizTalk Summit. Great lunch. For those who do not know me, I'm a program manager with the Service Bus team. We are part of the Windows Azure mobile workload or mobile team. And so what mobile has to do with integration, you'll see later on, but just tell you that Service Bus and BizTalk, we've been working closely for the last, 3 years. The poster you have outside is kind of a joint effort between Guru, myself, and Kent, who actually was the product, Kent, yeah. So I saw the poster. So that was our work from last year. And this year, we are still supporting the integration workloads, and we are also looking at new scenarios. So what I will do today is I will give a brief introduction to those who do not know or forgot what Service Bus is, and then look into what is new with the Service Bus, what have we done in the last year, and then talk a bit about the future. And I will share what I can share with this forum. Just before I start, how many of you use Service Bus to some degree? Okay. Just a sanity check, how many of you use BizTalk? Okay, fine. I guess I'm in the right place. So back to basics. Service Bus mainly supports 3 scenarios. The loosely coupled application, where you have an application with multiple components which need to basically one component puts messages in a queue and the other pulls from the queue. You get this load leveling. You deal with spikes. You don't need to provision the backend for the maximum load and just plan for the average load. And you can take off your backend while still having a front end posting messages and placing those in a queue. The other scenario or family of scenarios are related to the message-oriented middleware. So this is kind of messaging and pub-sub aspects of it. So you put a message on a topic, and then multiple receivers can pull this message based on all sorts of properties. And the third, which is really interested in the context of this summit, is the hybrid solutions, the hybrid scenarios, either on-prem resource to the cloud, and on-prem could be BizTalk server, and the cloud component could be BizTalk service. And I will talk about those scenarios later on. So core messaging, the idea is you have 2 components, 2 roles, and you want to scale each one individually. You want to have a resilient solution. So if, let's take a retail example, you place an order and the backend or the warehouse application is currently down, messages will just wait there in the queue and be picked up later on. And on top of this basic queuing capability, we have many, many advanced features and messaging patterns you can deliver. So this is kind of a laundry list of what you can do with Service Bus messaging. I'll just focus on a few of the new features we have introduced in the last 12 months. The second family is the hybrid, and the idea is, so the first use case is hybrid with relay, where you basically want to achieve location transparency. This is a turnkey solution. If you have a WCF service on-prem and you want to project just this service, this API, as a public endpoint to the cloud, a secured public endpoint, Instead of setting static IPs and poking your firewall and doing all those network dark magic, basically you can use the service bus relay and project just this API. It's a secure solution so that if someone managed to hack to your public endpoint, all they reach is your API. They don't really reach the server itself. And it is a secured endpoint with ACS, the Windows Azure Access Control Services. Earlier, Sam mentioned some of the tools to manage ACS, the SBAZ tool. So managing ACS is kind of a challenge, and we have approached this by adding more support for secured access signature, additional authentication mechanism. It's also a scale out. Again, you can have multiple instances of your on-prem server, up to 25. And if one fails, no problem. And we also deliver this load balancing for you. So the relay itself will kind of route incoming calls to different instances. The same scenario could be approached by using the broker messages, putting a queue in between the on-prem and the cloud components. And again, it's the same core messaging, but the idea is that you can reach out the queue from the cloud or from your on-prem. And the main difference between the two, if you think of it this way, is kind of the relay is more of a connectivity solution. You reach out, you call an API. If the server is not there, you'll get an error. In the queue, it's more of a brokerage. So you put a message in a queue at the broker, and later on it will be picked up. So it's messaging versus connectivity. Still in basics. So the idea behind the queue, you have multiple senders, multiple receivers from a queue. You get load leveling, so receivers will get messages at their own pace. Offlining, if the receiver stops receiving messages, it's okay. You basically can monitor the queue depth, but senders will keep sending messages. And it's important to realize that in a case of a queue, you have multiple receivers or multiple clients. There are what we call competing receivers or competing clients. Each message will be received by one receiver. And we guarantee that during what we call peak lock. So there are two receive modes. One is receive and delete. And in receive and delete, when I get the message is basically deleted from the queue. And if I fail to process the message is lost. In the other approach, peak lock, I receive a message from the queue. The message is still in the queue, but it is locked. No one else can receive the message. And then either I complete the message or I abandon the message, or if I crash, then there is a peak lock timeout. The default is 1 minute. You can set it up to 5 minutes and reissue the lock later on. And the idea is if I fail while processing the message, after this peak lock timeout, the message will be available for someone else to be picked up. So that's the basic queue. I'm sorry, I'm kind of going quickly over this. I hope this is kind of known for most of you. Topics, the idea is that multiple receivers need multiple copies of the message. So it's pretty much like you send the message to the topic, and then multiple subscriptions, each will get its own virtual copy of the message, and the receiver receive messages from a subscription. There could be multiple competing receivers for a specific subscription. And coming to think of it, a topic with one subscription is like a queue. Now, on top of those subscriptions, you can specify filters, and filters are defined using the message properties. Earlier today, Sam mentioned one of the best practices of just putting all the logic, all the payload as properties in the message. And you can do routing based on those properties. So for each subscription, you can define a filter in a SQL92 syntax based on those properties. And one of the patterns is to define partitioning. So I want to partition my incoming stream of messages based on partition ID. So those are runtime, those are dynamic rules. I can set the partitions. I can create a fourth subscription in this case and just add more rule and change those rules during runtime. Okay, that was the 5 minutes introduction. So we've been busy this year, and we try to approach 3 different aspects. One is to improve reliability of the service bus service. The other was to improve the developer's experience, provide simpler APIs. And the third was to approach new scenarios with new capabilities. So I'll start with just highlighting a few of the new features we have released earlier this year. We had basically 3 big releases in our cloud, and we'll talk about servers soon. So the first one is the one I really like because that was one of the top asks from developer. Basically, writing a receive message or receive loop and dealing with exceptions and completing the message is kind of a challenge. And honestly, we really didn't have a good example. Like our samples were a hello world type of samples. And what we've seen is customers couldn't pick up the value of receiving messages in an efficient way using asynchronous calls and so on and so forth. So we kind of added the option to basically specify a callback on a message and move into an event-based programming model where all you do is you create a queue client and you specify what to do when a message arrives. And you can decorate this logic by some hints to us. For example, auto-completion, the autocomplete. So instead, I mentioned the notion of a pick lock. So I receive a message, and when I'm done processing the message, I need to call service bus and say complete the message. With this on message, if I set the autocomplete to true, service bus client will do it for me. If I throw an exception while processing the message, service bus will take this exception and send this to the server. So it's kind of like the other options. And if I do not do anything still, the pick lock will expire and someone else will be picking this message. We've added the notion of concurrency, controlling how many concurrent calls to have. One of the interesting servicing loop challenges we had was with customers parking many asynchronous begin-receive calls, like I'm talking about thousands. And we suddenly throwing exceptions, and we had all sorts of KPIs. And there was a nice bug in our service that calling like when you reach 1,500 begin-receive calls, something didn't work as expected. And the main reason was that we've talked to developers, and they told us, hey, I don't know when to call the next begin-receive. Is this like, shall I wait for the next message until I'm done processing the message? When is the best time to call receive again? So we have simplified this by introducing these maximum concurrent calls, and you basically specify how many receive calls you want to park on this connection. So that's the on-message API. Second was authentication. So we had support for the Windows Azure Access Control Services. And if someone had tried, yes, in 90% of the cases, we see username owner and the default thing, because it's kind of very tricky to configure ACS. It's not built in to the Windows Azure portal, and we have released a tool, SBAZ tool, to help configure ACS, but we wanted to offer something simpler. And we kind of followed what the storage team offer, and we have this shared access signature authentication, where you basically define rules either at the level of the service bus namespace, and namespace is basically a collection of many, many queues and topics. So either at the level of a namespace or at the level of a single entity, being a queue or a topic. And in this rule, you can specify the claim, whether it's a manage, send, or receive claims. And you can do this either programmatically, or it's also fully supported with the Windows Azure portal. And you can have up to 12 rules per entity. And basically, this simplifies the authentication. And we highly recommend, especially in integration scenarios, where you have I have two partners who should be sending to one topic. I should have two different rules for those two partners, and never give the manage rule to the entire namespace to one of your partners, or even the application. It's kind of help prevent disasters. Third feature was introduced earlier, actually this year. That was the browse. In BizTalk, you have this message, fix, and resubmit. The ability to fix poison messages and actually analyze and debug the scenario. With Service Bus, we never had an option to pick up messages without actually receiving and locking them. So we have introduced this pick API, very simple pick call. You can specify either where to start from or batching and traverse, iterate all messages currently in the queue without locking them. A good friend of ours, which I will keep reminding, Paolo Salvatori, has his Service Bus Explorer tool, where you actually go and he used this feature to implement a fix and resubmit. There is only one caveat to this implementation. There is a little feature missing, which is if I fix the message I want to delete by a message ID, this will come hopefully soon. So this is a great feature to debug your application. I did not mention, but those using Service Bus are familiar with the dead letter queue. So a dead letter queue basically is kind of for each queue there is a dead letter queue used for expired messages, those messages which has time to live and no one processed them in time, or those messages where actually the client threw them back because they could not process them, the poison messages. And it's a great developers or monitoring or debugging tool, troubleshooting tool for your application to use the message browse. Additional improvement, now we talked about the receive loop, the on message and so on. Now let's talk about the send. So when you send a message and you get an exception, what do you do? And that question kind of, at least 1 year ago, that was like the number 2 question. The number 1 was the receive, and the number 2 was the send. So for each Service Bus exception, basically we decorate with an attribute saying is transient. And transient could be a network issue, could be throttling issue, could be a server unavailable issue. All those transients conditions where you need to actually retry again. And on the other hand, there are the non-transient, like the queue does not exist, or authentication error. So you need to deal with the non-transient, while the transient you basically need to retry. Now, how many times to retry? Shall I wait? How long? And so on. So we've captured this behavior into the retry policy, and this is kind of exponential timeouts. So we will start, you try to send, you get an exception, we will try send again, get an exception, all transient. So we will now wait 10 milliseconds, try again, 50 milliseconds, 100 milliseconds. So after a certain time, certain number of attempts, we will just bail out, say, hey, maybe this is not really transient. So this simplifies, and you can control this retry policy. So this simplifies dealing with exceptions for senders. So I showed just 2 simplifications, one on the receive, use on message, and one on the senders, the retry. By the way, I did not mention one of the a very important feature called session. So you basically, if you have related messages you want to be processed by the same receiver in the exact sequence, the exact order they were sent, you decorate them with a session. And one of the key asks when we released this on message was to support sessions. Currently this on message, I see people nodding, okay. It's coming really, really, really soon. So yes. So we will have basically like you have on message, we will have pretty soon on session. And you can just park the callbacks for the on session. And by the way, we had a customer who said, what do you mean you don't have support for sessions? I do. Look, I call on message and I keep getting the messages. And kind of we went back and forth like, what do you mean? It does not work. It shouldn't work. Like, and this customer said, look, I built a POC. And then we kind of realized that his POC had only 1 session. So yes, in the case of 1 session, it works. But if you have more than 1, please wait till we release probably SDK 2.3. Okay, the last feature I want to cover today is a feature we just released earlier this month, and this deals with throughput and reliability. So Service Bus is a multi-tenant service. We use many databases. It's a durable messaging, so all databases are stored in SQL, and we use like hundreds of SQL instances in each of our scale units, or stamps, as they call those. Being a multi-tenant service, you're often being throttled because of one of your neighbors. It's a noisy neighbor condition. Or we're often being throttled by SQL because someone else is using the same SQL, and so on and so forth. So one approach is to go with a dedicated resourcing model, which we are looking at for the future. The other is actually to create what we call partitioned queue or partition topic. And think of it as you have one queue which actually spans across 16 databases. So you have 16 partitions. So you get like the chance that 16 databases will kind of become throttled or unavailable is really low. But what you're getting is, first you're getting a bigger queue. For each queue and topic, we support up to 5 GB of size. But if you have 16 partitions, you can get up to 80 GB. And the sender and the receiver are completely agnostic to this partitioning. So the sender sent to the topic, and receiver will receive from a subscription. Okay, they don't know, they don't care that those are partitions across 16 fragments, 16 databases. And there are actually 3 cases where you do so when you send a message, you really don't care which partition it goes, with 3 exceptions. First being session. So as I told you, in order to guarantee sequential delivery of related messages, we need to put them in the same session. And this session will have to land in one specific partition. So the moment you use sessions, your messages are kind of partitioned by the session ID. The second case is transactions. So Service Bus supports transactions. By the way, it does not support distributed transactions. So what you can do is you can receive and send to the same queue within a single transaction scope. You cannot receive and store and save in database. This is kind of DTC, which we do not support. So if you use transaction to receive and send to the same queue or topic, you will need to specify partition ID, because in order to guarantee this transaction, we need it to be from a single partition. And the third case is the duplicate detection. So duplicate detection is a really useful feature where you may send the same message multiple times, and we will kind of remove those duplicates. So you specify a duplicate detection window on your queue or topic, and we will kind of throw the duplicates. So in order to guarantee that, we need this to be partitioned. So this is a case where we will use a message ID. And message ID is something that we automatically generate for each message, unless you tell us otherwise. So let's say that you have multiple workers picking up jobs from one pool. And it could be a case where 2 roles just pick up the same job. So this job ID will become the message ID, and we will make sure that only one is actually being processed later on. So those are the 3 exceptions why for messages to be actually partitioned, hard partitioning. The rest, we don't care which partition they land. It's kind of a load balancing. Okay. Next, let's talk about server. So we are the Windows Azure Service Bus, part of the Windows Azure Mobile, and why are we doing server at all? Good question. And the first reason we had, or the first answer is actually in 2012, we had one customer. And this customer was the Workflow Manager, Windows Workflow Manager 1.0. And Workflow actually had basically one customer, which was SharePoint 2013. So SharePoint 2013, there was a change in the way SharePoint processed workflows, the SharePoint workflows, and they decided to use the Workflow Manager. And we are actually the state and all the logic for the Workflow Manager based on topics and subscriptions. So we had an opportunity last October to release a server product to support Office, support SharePoint 2013. And beside this single yet huge customer, we started looking at other scenarios like messaging scenarios on-prem. And again, we are a cloud team, and we develop to the cloud, but then we realized that we want to somehow follow a cadence where we take what we deliver in the cloud and bring this back to server, hopefully once a year. So far we managed to deliver the first 2 releases of the Service Bus server exactly within 1 year. And for those who don't know the Microsoft release criteria and process, it's really tough. It's really pain to release a server product every year, especially compared with the cloud, where it's way more agile. So what we've done this year, we kind of released the 1.1 release of Service Bus Server, where we brought the support to the latest SDK at that time, which is the Azure SDK 2.1. And we also integrated with the Windows Azure Pack, which I'll kind of mention soon, as well as added supported to AMQP. So the big news for Service Bus on-prem is all the features available in SDK 2.1 are available on-prem, which includes AMQP support. It's a standard protocol I'll just cover soon, and Windows Azure Pack. So just to show you how busy we were this year, this is what we managed to do in the last 12 months, or actually 13 months. October, we released Service Bus 1.0, and this October, we released Service Bus 1.1. In between, we had like 3 major cloud releases and endless hot fixes and bug fixes in the cloud. It's way easier for us. And what you can take from this slide is more of the cadence, the cloud first, server follow cadence. So at any given time, probably the cloud, the Windows Azure Service Bus service will be newer. There will be some features available in the cloud which are not there on-prem. So if you need to develop an application which spans both, which you actually need Service Bus on-prem and in cloud, just pick the SDK which works with server. It will always work with the cloud. The other way around, not necessarily. And in this year, we looked at how customers use Service Bus server and came up with those 6 takeaways. So we saw customers using Service Bus within an application, the classic loosely coupled application. We saw Service Bus being used as an intro app, basically multiple applications exchanging messages between themselves. So they sit on a bus. And it's not an ESB. ESB is way more than messaging. It's just what we call MOM, message-oriented middleware. It's just plain messaging, high throughput, on-prem messaging solution. We've seen customers developing new applications, but more interesting is customers migrating existing applications. So those could be applications using some sort of a homegrown ESB, where they realize that it's a 10, 15 years old platform and they want something new. And it could be paid products when they realize that they are not really using the full feature set of, for example, an ESB product, and they just need messaging, and they migrated from paid product to use Service Bus. We've seen customers taking Service Bus and realizing that they have an application and they need some very simple adapter. So that's not really what we were looking for, but this came as kind of a few customers said, yeah, I have my homegrown application, and basically it's a file system based adapter, okay? So we are not trying to build a library of adapters. We're not sharing those adapters, but this could be done. It's a developer's platform. And we also seen customers using Service Bus for connected devices. Think of devices where cloud is not an option, like ATMs or printers within a corporate, or any devices which deals with sensitive information which cannot go to the cloud. So starting with the Service Bus 1.1, there are basically two alternatives to consume Service Bus on-prem. One on the right is what we call the Service Bus standalone. You download the library, you do everything yourself, and you can embed it in your own product. The other is part of the Windows Azure pack. I guess Scott Guthrie mentioned this yesterday. This is the Microsoft Private Cloud initiative, where you have multiple IT resources offered to tenants in a private cloud. And the Service Bus 1.1 was released together with the Windows Azure pack, the Microsoft Private Cloud initiative. This is a combined release of Windows Server, System Center, and few Azure components, including Service Bus and websites. So this is kind of a laundry list of what's available there. The idea is you as an IT department deploy this private cloud, and then you can offer tenants, either internal business units within your organizations or partners, or you may become a hoster and hosting your own application, and you offer your tenants services like Azure. How this being built is basically we have created symmetry between the Windows Azure public cloud and this Windows Azure pack. Come on. All right. So in Windows Azure, we manage the services, okay? While when it comes in a private cloud, you need to manage those services. So we have created the same stack of management APIs. This service management API is the key. So we expose resources, either on-prem or cloud resources, with the exact same API. Now, just give you one example, managing VMs. It's the same API, but completely different implementations. Okay, in the cloud, we have our Fabric, which provisions VMs, the IaaS, infrastructure as a service, while on-prem, this is just a System Center Virtual Machine Manager. So once they kind of share the same management API, basically you can write the same portal. You can write the same management experience. So the Windows Azure Pack portal, the tenant portal, looks exactly the same as the portal in the public Windows Azure. Now, in addition to this tenant portal, we also released an admin portal. So there are some operations that an admin need to do, which are not there in the public cloud. And I won't get into details, but basically when you install this Windows Azure pack, you get two management experience, one for the tenant, which is exactly the same one, seamless or consistent with the Windows Azure, and the other is the admin experience, which kind of extends System Center to some degree, but it's not as rich as the System Center management experience. I mentioned AMQP earlier. So AMQP stands for Advanced Messaging Queuing Protocol. And this is a standard initiated by the financial services industries. And the idea, the goal was to avoid this vendor lock-in. Coming to think of it, when you buy a messaging solution, it's kind of like you marry it, it's a lifetime engagement. It's really hard to replace a messaging broker because it's so fundamental in your stack, in your application stack. So the idea was to base the messaging on a standard protocol so that you can actually go and replace the broker later on if something new comes up or if you're not happy with your vendor. In addition, to offer real interop between multiple platforms. So just imagine us as being a messaging broker. We had to release multiple libraries in all the platforms, .NET and Java and Ruby and PHP and Python, and those keep coming and more platforms emerging, and we don't want to support dozens of libraries. So by relying on a standard protocol, we basically say, hey, we support AMQP 1.0, and we can certify few libraries, but basically if you have an AMQP compliant library, go ahead and try it yourself. And we have basically certified the Apache Proton libraries. And in fact, we have been contributing a lot. So we have recently integrating with, helping a Microsoft service to integrate with a partner who is Java JMS based. And they picked up the Apache JMS implementation based on AMQP. And the first Hello World worked really like in a day. But then after a week, we started seeing all sorts of issues, deadlocks, and all sorts of issues in this integration. And we have actually spent like, I would say, at least a month in improving the Apache JMS implementation of AMQP. So it's almost a win-win. And all the improvements we've done could be used against other brokers as well. So we are now contributing to the Apache libraries as well. And the fact is, if you have a Java JMS application, all you need to do is just take the JMS. JMS is just an API. So you just need to pick a JMS implementation which uses AMQP 1.0, and then you can exchange messages with the .NET application. So we have released this in the cloud back in May. It was announced GA in May, and now in October it's available on-prem as well. And it just opened a bunch of new integration scenarios between different platforms. You don't really need to build bridges yourself. Especially in the case of Java, if this is a JMS application, it's just replace the JRE. So talking about protocol heads, basically we support 3 protocol heads, or 3 messaging protocols. One is the classic SBMP, stands for Service Bus Messaging Protocol. That's our own proprietary .NET protocol, which we've been supporting since day one. And then on the right, you have the HTTPS. It's a REST-based protocol for all the languages, and basically this is useful for platforms which do not have any other libraries. And till, again, earlier this year, we had to release all sorts of HTTP-based libraries for Service Bus. We have the Java SDK, which is an HTTP-based library. It's way less efficient than the alternative, which is AMQP. So with AMQP, basically, we kind of agree on the protocol, and you can go pick up a library either from the Apache or from any other vendor. And the moment that we all kind of shake hands on the protocol itself, integration is pretty much seamless. Just a comment, AMQP 1.0 is pretty much completely different than AMQP 0.9. So if you kind of look into brokers or APIs and you come across an AMQP 0.9 implementation, it's not like one tiny fix, it's different protocol. So look into that. And we also are pretty active in the AMQP standardization and working groups. So we have David Ingham is one of the AMQP co-authors, and Xin Chen was kind of one of the key contributors of initial coding this AMQP thing. Okay, so since we are here in an integration summit or the BizTalk summit, sometimes we are asked still, hey, what's the relation between BizTalk and Service Bus, and is this one instead of the other, and what should I do, and what should I think of Service Bus? And we kind of start by admitting that Service Bus, the name itself, is kind of misleading, because customers initially thought of us as an ESB without the E. That's not the case. We are more of a messaging platform. And there are 2 key scenarios you should consider Service Bus and BizTalk. The first is the build versus buy. So Service Bus, as Mark showed yesterday, earlier in the stack, is a component in the Microsoft platform. If you are building your own thing and you don't really need the full richness of functionality, of transformation and monitoring and adapters and so on and so forth, you just need to exchange messages between A and B, then maybe just service bus is what you need. And by the way, our team supports also MSMQ. So I would go and say, hey, if all you need is to exchange messages between two processes on the same server, maybe you should consider MSMQ. But this is more of the build versus buy. If you need the full richness of integration capabilities, the EDI case studies, like no one will go and implement their own EDI. It's kind of clear, right? And there is a very straight line between what you may consider to build and what you should buy. And the reason I call it build, because Service Bus is on-prem is a free product, and it's part of the Microsoft stack. We require Windows Server license and SQL license. But if all you need is to exchange messages, maybe Service Bus is your solution. If you need more than that, this is kind of where you may want to reach out to a consultant or us, and we can kind of recommend you, hey, you may be able to do this by using WCF and something else. You may want to do this using workflow, or probably you want to use BizTalk. More of this is kind of your line of business. This is what you build your business on. You need the support. You need the muscle of BizTalk. So that's kind of where we stand. And the third wheel, which is actually the more interesting part, is where Service Bus and BizTalk shine together. And the scenario I'm going to show soon is, which was mentioned kind of countless times in the last 2 days, is the hybrid. So I have assets on-prem and something in the cloud. Could be BizTalk, could be BizTalk services, could be every, and this is where Service Bus and BizTalk actually shines together. We've seen just earlier, Sam, he basically kind of showed a great case study of this using Service Bus just to bridge between BizTalk and BizTalk services. So in the next 5 minutes, I will just talk about a few of those better together scenarios. Before I go there, I want to kind of give credit to a good friend of ours, Paolo Salvatori, who basically did all of those POCs or implementations. You'll have the deck. There is a list of all the scenarios he implemented. And if you go to his blog, those are really detailed implementation. All you need is just to follow the steps and you have it. The poster you can pick up on your way out has those two, it has actually 6 scenarios, but those are the 2 main hybrid scenarios we see. Service Bus and BizTalk, Service Bus and BizTalk services shines together. So the first is basically I have my application on-prem, and now I have this new trend of mobile apps. I need a mobile head. I need a native apps. I need HTML5. And with Windows Azure mobile services, it's really easy to build both native as well as HTML5 applications. But the problem is, how do I reach out to my backend service, to my backend assets, being database, being BizTalk, being any line of business application? So with the Service Bus, or let me start. With Windows Azure mobile services, you can define APIs and expose just APIs. And by hooking those APIs, using Service Bus, either Relay or the queues, you can reach out to your on-prem asset. That's the first category of scenarios, the mobile head, or extending your on-prem application to something in the cloud. The second is what we call hybrid, where you have logic both on-prem and in the cloud. This is a classic case is the BizTalk services. So I have logic in the cloud, but some logic still happens on-prem. It could be a point-in-time thing that I'm just starting to migrate my assets, my services to the cloud, and I still need some. It's like stepping on a chewing gum. I have some leftovers in on-prem. It could be that I do integration and the rest of the logic on-prem. So those are the 2 categories of hybrid scenarios which Paolo approached in the last 6 months. And those slides are basically his. The first one is a sample where you use Service Bus Relay to expose BizTalk server to mobile service. So let's say I have my application being, I don't know, like a pizza franchise, okay? I want to offer pizza mobile app to order pizzas, but all of my existing application to receive those orders is based on BizTalk. So with this hybrid scenario, what I do is I build a mobile service in Windows Azure and reach out to my BizTalk application using the Service Bus Relay in this case. And Service Bus Relay, I mentioned, requires ACS. So before reaching out to the relay, I need to go to the ACS and get a token. So it I secure the application with the relay. And from the network side, from the security side, on BizTalk, the BizTalk is still on-prem, and you don't really need to reconfigure your firewall or get static IP address and so on. So that's the first scenario. The numbers basically I copied it from his blog where he described this scenario and actually have this as a sample. So that's the first scenario when I take BizTalk and just put a mobile head. This is pretty much a similar scenario, but instead of relay, I'm using queue. So again, relay is kind of a connectivity solution where I need, for example, I issue a query to where's my reservation, where's my pizza? I'm expecting a reply to come soon. If I'm just posting an order, it could be that I can post it to the queue and BizTalk will consume it later on. That's the loosely coupled. Still, it's a hybrid loosely coupled solution. So BizTalk with the BizTalk 2013, the service bus adapter, so you place a message in the queue or consume a message from the queue. And in mobile services, you expose custom APIs which send and receive messages from the queue. Again, pretty straightforward. And building native apps and HTML5 apps with mobile service, pretty much straightforward. Next set of hybrid is where I moved my logic or my integration to the cloud using BizTalk services. And still, that's the chewing gum. I have some resources, either hosted as a WebCF service in IIS, or we mentioned BizTalk earlier, but the idea is that now my logic running in the cloud in BizTalk service want to make calls to my on-prem. In this case, it was a calculator service, but it's kind of logic still on-prem. So using Service Bus, you get this location transparency. BizTalk service just makes the call. And all the network, all the magic is taken care of with Relay. This this diagram is another scenario where you show the power of mobile services using Service Bus to reach out on-prem solution. What it also mentioned here is the push notification or the notification hub. Can you raise a hand if you have heard or used the notification hub? Okay, good, about 50%. Okay, so for those who did not use it or wanna, you should try it out. It's a new service we developed, our team developed it, and it's part of the Windows Azure mobile services. And the idea is that you wanna send push notification, tiles, live updates, all those mobile platforms being iOS, Android, Windows Phone or Windows 8. And you want to send them once, like it's kind of a pub sub of those notifications. And you want to send them and you don't care about the platform. So you just place them in the notification hub. Think of it as like a topic. And we have subscriptions with the multiple push notification platforms being iOS and Google and Microsoft. And one of the applications, actually the first application used this was Bing News. So if you have a Windows Phone or Surface or an RT or Windows 8, you open the Bing News and you can register to areas of interest. What are you interested in? You're kind of interested in sports or in business or in world news. And if something happens, then you'll get this live tile in Windows 8 or push in your mobile device. And that's the first application which used push notification. So from mobile services, you can reach out to the push notification or to any other on-prem resources using either queues and relay. It kind of all fits together. The interesting part here is that the identity is via a third party. So you have an authentication provider being Facebook, Twitter, or others. And again, those are all part of a very long list of hybrid scenarios from Paolo. So I heard it earlier today, like the Paolo stack or the Paolo solutions. And again, Paolo could not come here, so I hope this is recorded. Thank you very much, Paolo. Okay, so for the last 5 minutes, I want to talk about what next. And again, I cannot share much of dates, but we are kind of going to improve reliability of service bus, keep improving reliability. And one of the things we will roll out later this year will be something like a guaranteed SLA or using guaranteed dedicated resources. So today I mentioned service bus being a multi-tenant platform. We cannot guarantee SLA. We cannot guarantee any performance or throughput. And there are some customers who expect to see that. And for that, we will roll out a new SKU in a way, where you will have your own compute resources and storage resources, and basically you will be able to know what to expect. That's one thing. The other is, some call it volatile messaging, we call it lazy write. There are cases where you want better throughput at the cost of durability. Let's say you send telemetry data, and you may be okay with losing, I don't know, 5 minutes of messaging. And for those scenarios, what we're going to do is we're going to cache those messages in memory, and then later on write those to the database. And if you have a fast send and receive, they won't reach out to the database at all. So you will get higher throughput, like at the cost of, if we crash or if a specific node crash, you may lose a few messages. So this will be kind of a durable or a lazy write messaging. Now, I just call out those two. There are a few more, but what I want to talk about is what we call device to cloud. Some may call it IoT, some may call it M2M, but basically, we in Microsoft see this as the next wave. And when I say device to cloud, just imagine how connected devices or smart devices will influence basically our life. So it starts with the smart mobility, so like connected car. Last year, by the way, Delphi released a plugin to your car. They use Service Bus. It's a Delphi Verizon plugin. So it's a OBD-based connector, and they send with Verizon Verizon cellular connectivity to their service, so you can know where your car is. You can unlock your car from your phone, so on and so forth. So this is like the first smart mobility customer which used the Service Bus, and we've learned a lot from working with them. But nowadays, I read somewhere that by 2018, around 35% of cars sold in the world will be connected, will be smart. And it's a telemetry thing, and it's a location awareness. And some may use this connectivity to make your car as your next, living room in terms of streaming media and so on. That's the smart mobility, but it's more than cars. Think of trucks and fleet management and cargo and trains and everything being connected. Then it's a whole new set of solutions and opportunities. Next is the grid. So I heard kind of in the UK or in Europe, it's more popular to connect the power grid and the gas grid and the water grid and whatever grid you have. Just make your meter smart meter, connected meter. And the idea here is that you take an existing product which is relatively cheap, you put some electronics, you make it connected. The product itself is still not smart. What makes the story smart, or what makes it interesting, is the backend services, where you can analyze your power consumption or detect issues in your pipeline or whatever. We've been talking to all sorts of grid providers or service providers. Then the home automation. Again, we've been hearing this home automation for years now, connected home. doors, thermostats, lights. You know, a few of us have the Nest smart thermostat. I saw demos of the Hue light bulb. But it's more than that. Just imagine, you know, when I tell this story, I just tell my wife, what if we had small cameras inside our fridge? And when we go shopping, actually, I can look at what currently inside my fridge, because I always buy too much celery, whatever, or broccoli or whatever, those things which just last in the fridge. Well, you know, if you ask me what would be a smart fridge like 2 years ago, I would say, wow, that's a fridge with a panel which scans everything, like a barcode. But nowadays, you know, all I need is a webcam inside the fridge, and I need to see what's in there. And next is someone will take those pictures and analyze them and actually tell me what I have there. So I just wait for Amazon with their Amazon Fresh come up with this thing. It's kind of really will make my shopping experience different. Anyway, smart buildings. Think of lights, gates, doors, air conditioning. You know, we always talk about better utilize your resources, and having those connected devices inside our buildings and commercial buildings mainly can improve our. It's always start with ROI within a year. So by turning off all lights at 5 p.m. or AC or whatever gates, or it's kind of the story is pretty straightforward. With connected devices, take existing devices, make those connected, and make the services, the cloud story. That's where the smarts is. Smart factories. Anyone from Europe, the Factory 4, it's kind of we kind of hear it a lot from customers in Germany, that all the floor, the plants and manufacturing actually is all about connected machinery. And the story I show, I think it's public, that there was a company who selling those big generators, like $1 million generator. And the number one pain point was that this generator uses 4 air filters, each cost $40. And the problem is, like, when those 4 filters are not working as expected, the generator will shut itself, because otherwise it will kind of catch fire. So with a very small investment, they managed to track the health of those filters and send this to their support center, whatever. And the logic was pretty simple. When 2 of the 4 are not working as expected, they will send someone with 4 new filters. It's $160 equipment. And then they save on maintenance, because they don't need to ship 2 generators for the fact of having 1 active and 1 failover. So that's kind of a very interesting story about manufacturing. And logistics I mentioned. So if we look at all of those stories, we kind of can realize that the smarts can come from the service, from the cloud. It will come when you use the analytics power and storage for the telemetry data. It will come where you have dashboards of alerts and enable those alerts to your mobile phone. It will come with integration to external systems. This is where just you guys use BizTalk. Think if you can enhance your BizTalk with some sensor data. If it's a shipping company, like the moment the package leaves the door or the moment the machine goes down, just kick this workflow or alert and so on. And with SaaS solutions, we hear a lot about CRM and well, not mention Office. Office 365 are really looking into the next wave of Office 365, leveraging connected devices. So with this, it's kind of the way we see it is, for us in Windows Azure, we have a great opportunity because of the rich set of features and capability in the platform all up. And I'm standing here talking about this because we think that Service Bus, as being the cloud gateway for telemetry data from devices and command messages to devices, could be the piece which will kind of open the gate for a flood of new solutions and services. So what we are going to do next year is we're going to launch a customer adoption program around those device-to-cloud scenarios. We will reach out to our partners and friends who are looking to engage with us starting probably Q2 of next year. If you have a case or if you have a consultant and you have a project you want to try and build a muscle around the IoT, please reach out to me or anyone from the Service Bus team or your Microsoft account manager. We will kind of send out a nomination survey later on this year, and that's basically our next challenge. With 22 seconds, I have a so yeah, we have 15 seconds for, no, kidding. Any questions? Yes?
To do with the Azure Pack, are there any plans to migrate compute services to that as well?
Compute is there.
It is there?
Yeah, compute. So you achieve compute by VM. So what we've done in the Azure Pack is we're taking VMM, which used to be an IT solution, but when we wrap this with the same APIs as in the compute nodes for Azure, you get a tenant experience. You can provision a VM based on a pool of resources assigned by your IT admin.
But can you provision a web role?
Yes. No, sorry. Oh, okay. So you said compute. Okay. So yeah. So the PaaS offering, the web role and worker roles are not there in this release. Sorry. But you can provision a website. The Azure website is there, and VMs for hosting.
But the big thing is, wondering whether there is a roadmap to support the PaaS.
I am not the guy to answer this question. I'm sorry.
Can you point that?
Sure. I'll give you my card and I'll forward you this question. All right. Yes. Is Service Bus HIPAA compliant? Not at the moment, no. I cannot comment on that, I'm sorry. Plan, yes. Date, I don't know. Yes?
So do you see the plumbing that your team is going to build, or the broader team is going to build for these IoT end-to-end scenarios being, I guess, reliable enough to support regulated industries like oil and gas, workers, healthcare, HSE-related reporting, and you can't have 10 minutes of messages disappearing because something could blow up, right?
Yep. So the question was, it's more, so regulated is one, reliable is actually, I can answer about reliability. Right. Regulation, so the thing with regulation is this IoT is still, I call it the Wild West, like everyone popping new standards and new protocols. And so regulated will probably come later, not in...
When I say regulated is that you can't have 10 events disappear and
Yep.
because of lack of reliability. That's what I mean by regulated versus HIPAA or something.
Sure. So let me put it this way. It's good because when we talk to customers, they said, yeah, we have some applications will never go to the cloud because of reliability. And the way to go there is it always has to do with the last mile. So you'll have some gateway, which is highly reliable on-prem. Could be at your home or at your building or at your company. And you'll need some store and forward patterns. So you'll have a reliable communication to some close by. Because nothing, if you look at monitoring oil and gas, you cannot rely on cloud connectivity by definition. Unless you have like a cellular and satellite and whatever, a white space all together, because connectivity may go. And we, as Service Bus, will be reliable. So when we get a message, we won't drop it. But if you're looking about achieving end-to-end reliability, you probably have to do something on-prem or close by.
Caching until
Yeah.
the message is guaranteed.
Yeah, exactly.
Because, you see the international remote location scenarios where they might not have the plumbing to go to a big network pipe. Maybe a cloud is a good economy to scale.
Yeah.
Right?
Yeah. So let me put it this way. For an early adoption program, we're not looking for the guys building pacemakers or or any device which may result in someone not feeling well. Okay. Any more questions? All right. So thank you for having me, and enjoy the rest of the day.